Alright, so for number 1, they want you to continue the story where they left off. And as you can see right here in red, they begin to float up as their house lifts off the ground. So that's represented right here with this segment. As time goes on, the distance from the ground is increasing. Okay, right here. Then, after a little while, they maintain their distance from the ground. So, as time goes on, right here, the distance is constant from the ground. So, all of, like, this distance is the same. But then a burst of wind lifts them higher. So, here, as time goes on, they're going up higher and higher. Okay, so we're going to pick up from here. So, we're going to explain what happens here, what could have happened here, and what could have happened here. Okay, so maybe in this segment, so we'll change the color. So like right here, we could say that maybe some balloons popped. You know, or the wind let up. So they went down a little. Okay, so maybe some balloons popped, so you know their elevation is decreased, or the wind let up. You know, so the wind just kind of died out. So they went a bit down. Okay, and then we have this segment right here, where again, for a little while, they maintained their distance, or the height, the same height. Okay, and then last but not least, we have this piece right here, where it could be that the just move this up a little bit, a stronger, or the wind came back. Wind came back and lifted them higher. Okay, that's it for number 1. Alright, so for number 3, you are identifying the domain and the range, and explain if the relation represents a function or not. So for the domain, remember, domain is your input value, your x value. So that would be this one, this one, this one, this one, and this one. Okay, and you see these numbers right here. The range is the output value, or the y value. So that would be this one, this one, this one, this one, and this one. Okay, and that you see the numbers right here. Explain if this relation represents a function or not. Yes, it is a function. One way of explaining it is because the x's don't repeat. If you look at your x's, -5, -4, -3, -2, -1, they don't repeat. So every input, I didn't finish writing it. Every input goes out to one output. To only one output. It doesn't go out to different outputs, so it goes out to only one, or a unique output. Okay. Right, so for number 3, it's saying that the function f of x equals 17x represents the number of pull-ups f of x you can do in x minutes. How many can you do in 4 minutes? So you are writing f of 4, because you're replacing the x with a 4, and 17 times 4. So that gives you 68. So in 4 minutes, you do 68 pull-ups. Okay. For number 4, we are going to subtract the, well, you could do it either way. Let's go ahead and do it this way. Let's distribute the negative 2. So here and here. So minus 6x, and then negative 2 times negative 1 is plus 2, equals 12. And so now we're going to add these two, so we get 8 minus 6x equals 12. So now we're going to subtract 8 from both sides because we want to isolate the x, we want to leave it by itself. So let me just continue here on the side. So negative 6x equals 12 minus 8, which is 4. And then we divide by negative 6 on both sides. That's a 1. And then reduce your fraction. So then this gives you x equals negative 2/3. Okay. Number 5. We are solving for b in this problem, so we want this b by itself. Okay, so we're going to subtract the ch from both sides. So ch minus ch is 0. On the left side we have s minus ch. We cannot combine those because they're not like terms, right? So it's going to be 2b. We want this by itself. We want to isolate it. So we divide both sides by 2. So 2 over 2 on the right is 1. And so what we have left is this answer right here. Alright, number 6. Again, our goal is to isolate the x, leave it by itself. So first thing we do is we add 4 to both sides. That gives me 0 there. 2/5 x equals negative 10 plus 4, that's negative 6. And we want to isolate the x, so we divide by 2/5, which is the same thing as multiplying by the reciprocal of 2/5. So times 5 halves on this side, 5 halves on this side. Again, just to not mix up the numbers, let's make them both fractions on the right. So this is 6 over 1. So that's 10 over 10 is 1. So now we've isolated the x, and you can either multiply across and say negative 30 divided by 2 is negative 15. Or if you wanted to, you can reduce like the 2 and the 6 to 3 and 1, and it would have given you negative 15 also. Okay, so the answer is x equals negative 15. Alright, so for number 7, we're going to distribute the 2 first, right here. 2 and here 2. So that gives you 2x minus 12 plus 2 greater than 4x minus 18. So I can combine like terms right here. So 2x minus 10 greater than 4x minus 18. Okay, so now you have a choice to make. You can either move the x's to the right side or move the x's to the left side. It's up to you. I'm going to show you moving the x's to the right side. To the right side. Well, let's do this. Take it back. Let's move the x's to the left. And so that gives me 0 there. Negative 2x right here minus 10 greater than negative 18. So I'm going to add 10 to both sides. And I'll continue the work over here on this side. So this is 0. Negative 2x greater than negative 18 plus 10 is negative 8. We're going to divide by negative 2 on both sides. So now x is less than, because since we divided by a negative, you have to switch the direction. X is less than positive 4. Okay, that's my answer. X is less than positive 4 is right there. Number 8. Write an expression to model each of the following. So we have a monthly fee of $65 plus a $45 initiation fee. So monthly fee, that means that you're going to pay $65 every month for as long as you're a member of this this program. and an initiation fee of 45. So this you pay at the beginning, and that's it. It doesn't get added or charged to you again. So the 45's constant. What changes is the $65 a month, because every month you're in this program, you're paying $65. So that would be 45 plus 65. And again, you could write it 65M plus 45. And M represents the number of months that you are in the program. Okay? An hourly wage of $9.50 plus $150 stipend. So right here it changes hourly wage. So per hour it's $9.50. The constant is the $150 stipend. So it doesn't matter how many hours you work, you get the $150. Whereas the $9.50 is per hour. So you could put $9.50 H for hour plus $150. Okay. Or you can write it as $150 plus 9. And I'm writing both ways because when on a multiple choice test, it could be written either way. So these two, of course, are the same. And H represents number of hours. Okay. For the third one, a startup fee of $50 plus a weekly fee. So the startup fee is what you pay at the beginning, and then this is going to change. Every week you're going to be paying that $12 fee. So it's going to be $50 to start up, and then after that, $12 per week. And then again, you could switch it and put 12W plus 50. These are the same. Okay, and then the last one, we have a charge of 5 cents per minute plus $1.50 connection fee. So again, the cost that's going to be changing is the 5 cents per minute, right? The more you use it, the more you pay, 5 cents a minute. The $1.50 is you pay that one-time fee and that's it. So whether you use it 5 minutes, 100 minutes, 1,000 minutes, you'd only pay $1.50 for connecting the phone. So it's going to be 5 cents per minute plus $1.50. And again, you could switch it out and put 150 plus 5 cents per minute, so 5.05 M.